Medical gas lines, contrary to some assumptions, do not require electrical bonding. This point often leads to confusion, stemming from the general understanding of bonding requirements for metallic piping systems within buildings. To clarify this, it's essential to understand the purpose of electrical bonding and how it relates to different types of piping. Electrical bonding, in general, serves to create an electrically conductive path, ensuring that all metallic parts of a system are at the same electrical potential. This is crucial for safety, particularly in preventing electrical shock hazards. When a fault occurs in an electrical system, such as a live wire coming into contact with a metallic enclosure or a metallic pipe, the bonding system provides a low impedance path for the fault current to flow back to the source. This high current flow triggers the overcurrent protection device, like a circuit breaker or fuse, to quickly disconnect the circuit, thereby preventing a dangerous voltage from remaining on the metallic parts. The National Electrical Code, or NEC, provides detailed guidelines for bonding various systems within a building. These guidelines are primarily focused on electrical systems and metallic piping that may become energized due to a fault in the electrical system. The NEC mandates bonding for metallic water piping systems, gas piping systems, and other metallic systems that could potentially carry fault currents. The reasoning behind bonding these systems is that they often extend throughout a building, potentially coming into contact with electrical equipment or wiring. If a fault occurs, these piping systems could become energized, posing a shock hazard to anyone who comes into contact with them. However, medical gas lines are different from typical water or gas piping systems in several key aspects. Firstly, medical gas lines are specifically designed and installed for the delivery of medical gases such as oxygen, nitrous oxide, and nitrogen within healthcare facilities. The installation and maintenance of these systems are governed by stringent regulations and standards, primarily those established by the National Fire Protection Association, or NFPA, specifically NFPA 99, the Healthcare Facilities Code. NFPA 99 provides comprehensive requirements for the safe installation, testing, and maintenance of medical gas systems to ensure patient safety and prevent hazards. Secondly, medical gas lines are typically made of copper or stainless steel, which are excellent conductors of electricity. While this might seem to support the idea of bonding, the critical factor is that medical gas lines are not intended to carry electrical current. Their sole purpose is to transport medical gases, and the systems are designed to prevent any contact with electrical sources. Thirdly, the grounding and bonding requirements for electrical systems in healthcare facilities are already extensive and cover all electrical equipment and systems within the facility. These requirements are designed to minimize the risk of electrical shock to patients and staff. The electrical systems are grounded to provide a low impedance path for fault currents, and all exposed metallic parts of electrical equipment are bonded together to ensure equipotentiality. Given these considerations, the specific requirements for medical gas lines focus on gas purity, pressure regulation, and leak prevention, rather than electrical bonding. The NFPA 99 code addresses these aspects in detail, outlining procedures for the installation, testing, and maintenance of medical gas pipelines. The code emphasizes the importance of using approved materials, proper jointing techniques, and regular testing to ensure the integrity of the gas delivery system. Moreover, medical gas systems often incorporate various safety devices, such as pressure relief valves and shut-off valves, to prevent overpressurization or leaks. These safety devices are designed to protect patients and staff from potential hazards associated with the gases themselves. The absence of a specific bonding requirement for medical gas lines does not imply a lack of safety measures. Instead, it reflects a comprehensive approach that prioritizes gas system integrity and compliance with NFPA 99 standards. The electrical safety within healthcare facilities is addressed through the extensive grounding and bonding of electrical systems, ensuring that any potential electrical faults are safely managed. In summary, medical gas lines are not required to be electrically bonded because the focus is on maintaining the integrity and safety of the gas delivery system itself. The extensive electrical grounding and bonding requirements within healthcare facilities adequately address potential electrical hazards, making specific bonding of medical gas lines unnecessary. The design, installation, and maintenance of medical gas systems are governed by NFPA 99, which provides comprehensive guidelines to ensure patient and staff safety. These guidelines emphasize gas purity, pressure regulation, leak prevention, and regular testing, rather than electrical bonding. Therefore, the absence of specialized clamps for bonding small copper medical gas lines is not an oversight but a reflection of the specific requirements and safety considerations for these systems.